Welcome to another GCBASIC demonstration. This is part 15 for the PIC18FxxQ24. So what we're going to be looking at now is external interrupt. And actually, I'm going to show you another interrupt program as well, but this is external interrupt because that seems to raise some confusion. Relatively simple in GCBASIC. So like and subscribe. The metrics are really important. Let the video run all the way through, and then at the end of it, like it, etc. Because they measure absolutely everything. So, part 15, using an external interrupt to control an LED is just a representative control of an LED. It's actually the principles of external interrupts that are important. But interrupts, we'll touch on interrupts in general again, because it's quite interesting. So I'm assuming you've installed the software, that you have a programmer, you've got a Q24 installed, you have 4 LEDs, that you have a potentiometer, some switches, and a USB TTL converter. And here is my chip, my Q24. These are my 4 LEDs. I have a switch connected through this white cable onto port A3, potentiometer, programmer here, PIC18F, and my serial connection has come off, but do I care? Because we're not going to be using it. So let's get into the subject about power domains. I've mentioned this repeatedly, and I will keep banging on about this. I am not using the VDD-IO2 power domain, which is the power domain in this particular video. I'm not using anything on this green zone here. If I were, I would have to apply voltage into here for that power domain. That is separate from the VDD for the chip, which I have set to 5 volts, just so you realize I do have 5 volts attached into here, but I'm not using that power domain. Really important. So what am I using? I'm using port A here. I've got a switch, been attached the whole time. I've got 4 LEDs on port B 0, 1, 2, and 3 respectively. LEDs, just seen those. And I have got, we're supposed to be connected to C.6, not using it, but it is connected. And you just saw those out in the camera. So those are the 4 LEDs, and they're hooked up via these flying leads. And we've seen those in the previous videos anyway. So let's look at what these interrupts are all around, okay, or about. So interrupts are things that stop the normal execution of your program, You defined an interrupt, and it will stop that program, that normal execution. It will go and do what you define as being the interrupt handler, and then that permits you to respond to external or internal events like a timer. It really, really has some huge advantages in terms of its responsiveness. It uses the microcontroller extremely effectively. And you might have very different types of interrupts. We're going to look at 2. We're going to look at an external, and we're going to look at a timer. You could have other peripherals generating interrupts. Serial is a really good example. ADC, another good example. And software, you can raise your own in software. The key registers that are used is something called INTCON, and PIE 1 and 2, and PIR 1 and 2. And they are the enable registers and the request registers, respectively. And you always have, in the quote general case, an interrupt service routine, ISR. There's a special routine that executes when this specific event occurs. They must be as short and efficient as possible. It is not the view of me. That is a really good practice. Do not do long-running processes inside an ISR because nothing else in the program is being operated at that time. So don't, avoid major delays inside of your ISR. Set a flag and get back into the main program. Interrupts. There are so many interrupts. I just listed these. This is from a previous chip. Let's look at the real ones. Well, we can do that by actually going out to let's look at the actual interrupts for this chip. Function key F4, and if I bring up PIC info, we can look at the we can actually look at all the interrupts. So if I put that over here somewhere, I zoom in on that. Here we go. Look, we can look at in here. There's a tab. I have selected the Q26 as my chip. Interrupt tab over here. Look, here are all the interrupts. So they start off with a 16-bit universal timer. There's obviously a 16-bit timer, ADCs, DMAs, external interrupts. Ooh, are we going to be using that one? Maybe not. Maybe we are. I2C, the logic cell, logic cells, port AB change. That's the one that we're going to be using. PNW, they have matches, SPI, timers, and USART, and voltage failing. So all those set registers. They set an event if the enable bit has been set. And so in here, this lists for you the interrupt, the enable bit that has been set automatically by GCBASIC, and the event bit that is automatically handled by GCBASIC. So if we look at the specific one that we're looking at today, it will be port change. It will set the IOCIE, which stands for interrupt on change, interrupt enable, and it will set the IOCIF, which stands for interrupt on change, interrupt flag, and it will manage those two for you. You don't have to worry about it. GCBASIC's clever like that. Back to my PowerPoint. So the one that we're going to be using is port AB change, and I believe there's a shortcut to that, which we'll look at. I think it's just called port B, port change, because AB is a legacy one. I think there's a much later, is a more generic name that we'll be using, but a huge amount of interrupts available. So interrupt on change is the one that we're going to primarily use, and it detects the change of a state of a pin, and it does that in hardware. And what it does, you set the configuration as an input, you configure a register for the edge. So do you want it to be rising or falling edge or both? And you have to set a register. Then you must have this ISR. And generally you set up the global interrupt enable to make sure it all works. But a lot of that is simplified in GCBASIC, and we'll look at the code. But essentially what we're looking for is detecting a change on a pin. We've set up the I/O port correctly as an input. We've set up the register to say I want it to be on a falling or rising edge or both. Got my handler, ISR, and then I enable it all. How do I know, though? How do I know what to do? It's really complicated. This is all very complicated. It's not. Let's look at IOC as an example. Interrupt on change. Here is table 3.3-1 for the 28 pin that I'm using. I've selected RA3 as my switch. I look at IOC, the column, and the name of the device, the name of the register bit I need to fiddle with is IOC-A3. Do not assume that name for anything else, but always check the data sheet. How do I check the data sheet? Well, if you go back into PIC info and you go to the front tab, you can just click on data sheet, and that will open for you the data sheet. Couldn't be easy. You don't have to go hunting around. In this case, I'm just going to go Control F, table, was it table 3-2? I can't remember. But let's have a look. Oh, there it is. There, look. And there is the table I was just previously looking at. And here is the article. There's lots of different interrupt on change that I can detect, but I want to handle this one. IOC-A3. Need to do something with it in a bit. Okay, how do I do that then? Well, what I'm going to do is I'm going to set that to a value, and I'm going to set that to detect an edge. I'm going to set up, and I'll look at this in detail, on interrupt port change. That's the command we're going to be using, call interrupt handler. And here is my little routine. Here is my interrupt handler here. And basically, we'll look at that, we'll zoom in on this, and it will set an LED and then clear a flag. So I've set the flag here to negative. I've set it to negative, look, IOCAN3 is negative, and then I just need to clear the flag down here. IOCA, that's a flag on the third bit. So IOCAF3, that's the flag bit. So let's have a look at that in a real example, shall we, to make it clearer. Control B to see the programs. I'm going to select program 215. Control B to shut that down. Let's look at the top of the program. I've got the chip selected, no PPS, standard header, and I've got my port here, A.3, set as an input, and that's the one I'm going to be handling and managing. That's exactly the same as we've had throughout all the demonstrations. Here is the main program, and I'll push the interrupt handler below. It says here, IOCA3, and I want it on the negative when I push it down. Okay, that's the flag I'm going to set. And here is my handler. On interrupt, that's the GCBASIC command, port change, call that handler. And it will only go there when the port changes. It's really simple. We can test for many different port changes now, but in this one, I can say, interrupt on change, port change, call my handler. What's in my handler? It says, set a bit variable, save the state. Not quite sure why I'm doing that, to be quite frank. I think this would be quite adequate. There we go, look, that is quite adequate. I'm toggling LED 3. Whenever I push it, it's going to toggle LED 3. Then you must clear the bit flag. We manage or GCB manages the enable flags, the big flags, but you need to manage the local flag. And that local flag was here that was set the negative going edge, and this clears that flag. Otherwise, it will never clear. It will just get stuck in a little loop. So we've set the enable bits. Function key F5 to program it. Go out to my desk cam so I can see what's happening. And what I did in my main program here is I've flashed LEDs 0 every 25 seconds, and you can see that it's flashing. When I push my switch, which is this switch here, the LED changes. And it's toggling it exactly as it should. Too simple. But what's going on? Well, this command here sets up the global interrupt for you. It sets the registers that we saw inside of. It sets the registers, the register bit, inside of here automatically. IOC enable. We saw that before. Here we go. IOC. It sets that automatically. It clears the flag automatically. All you have to do is tell it which edge, and when the event happens, clear that flag. Oh, there we go. It's working. Now, I have not put in here, in my interrupt, a debounce. You need to put a debounce in. I'm just showing you the interrupt. It's really, really simple. Very easy. On interrupt port change, and you can change that for any of the valid interrupts and then have your handler. You can do tests inside of your handler to see what event happened, etc., etc. GCBASIC will cache any variables or system variables that need to be cached. It will look after that in the environment for you so that you can go in and out of your interrupt handler with ease. Let's just change tack slightly and look at one of Hugh's oldest demos. This is the same header. I'm not going to look at it. And this one is a motor controller. I'll program it and then we'll have a look at it. Essentially, what this is, it's a motor control. Maybe I should change the LEDs. Yeah? Didn't test it, did I? Just program it. We'll come back to the explanation once we see it operating. So this is for a motor controller and how you can control a motor using an interrupt. And so if we look at the LED now, the LED is changing intensity. It's generating a pulse width modulated signal to control a motor. And it's rising in terms of its intensity and then dropping. Therefore, something must be changing the power or the duty cycle. And how's that happening? In this really simple routine. It says here, we're going to control a motor on LED 0. Yeah, it equates to it. Initialize a motor control. What does that do? Well, we have a routine in here that you might start to recognize. It says, clear some variables, motor 0, and a PMW counter. And we're going to use a counter to control the duty. And look, all I want you to draw your eyes to is this. On interrupt, timer 0, call a PMW handler. So you can use interrupts, software timers. This is the internal timer. I've set the frequency of it. I've just said, just run it, just get it running, and then start the timer. And then in our handler, in our PMW handler, it actually just does some very simple mathematics and says, it just does a counter and says every time if the motor is less than 100, then turn the motor on and off depending what our counter is equal to. So our counter might be equal to 1, it will set on 1 pulse and 99 would be off. And then 1 pulse on would be for 2. The next time it would increment that by 1, it will go 2 pulses, 98 off, 3 pulses, etc. It's a very simple motor controller, but the art here is this is how you use an interrupt that is actually being passed out to an interrupt handler. Extremely simple to set up an interrupt overflow, and it could be any of the timer overflows, and we've seen how many timer overflows in here. If we look at zoom in on here, how many timer flows we've got in here. We have timer 0, timer 1 gate, timer 2, timer 3, and matches on 4 and 6, sorry. So very, very intensive ability to really showcase timers. But again, this is about on interrupt motor controller. Really simple. Back into PowerPoint, because that's what I wanted to show you. So next time we'll be looking at storage in the chip. That's program memory, SIF memory, EEPROM, and what's called data blocks. And it's very different. It's not about LED. This is around how you can control memory. Enjoy.